morning students. So in this video we will discuss our chapter 11, that is force and pressure. So at first let us know what is force. See, force is nothing but a push or a pull on an object. Okay, now let me give you some examples like kicking, lifting, opening. What you do? While kicking we push the ball, is not it? Now while closing and opening drawer, what we do? We pull it while opening, and while closing we push it, is not it? So we can say that a force is nothing but a push or a pull on an object. Okay, so now we will see our next topic, that is force are due to interaction. Now students, see what happened. For a force to come into play, what happened? Two objects must interact. Suppose we will take object A here and object B here. Okay, suppose you see object B is a football and object A is a boy. Okay, now you see what happened. If this A, okay, if this boy do not touch the ball, okay, will the ball move? The ball will not move. The boy have to kick the ball, is not it? Then only the ball will move from one place to another. Okay, one more example is given in your book. What happened? A man is standing near a car. Okay, if the man is standing near a car, will the car move? The car will not move. The car will move only when the man will push the car. Okay, this A should apply force on object B. Okay, this is called what? Interaction. Understood? So from this we can say that force comes into play only when two objects interact. Okay. Now the third one is exploring force. So you see, for understanding this exploring force, what we need to do? We need to do one activity which is given in your book 11.2. Okay. So at first you have to choose an object like a table or a box which you can move by pushing very hard. Okay. Now you have to shift this box from one room to another. Now you are not able to push this one. So what you will do? Okay, you will call your brother and sister, is not it, to push this box from one room to another. So what will happen? This box will move to another room very easily. Do you know why? So what happened? You see, when the force is applied from same direction, it got added up. Suppose your brother is applying 10 Newton, you are applying 5 Newton and your sister is applying 10 Newton. So the total force here will be 25 Newton. Okay, we will add all the three forces, okay, applied from the same direction. Got it? So that is the reason what happened. We are able to move heavy object when 2 or 3 people help us. Okay. So now one more. Two conditions are given in 11.2, is not it? Now it is told that, now condition 2, you see what happened. In condition 2, you have to apply force from opposite direction. Suppose you are pushing this box from this direction and your friend is pushing box from this direction. Okay, now you see what happened. Here you both are applying force. If the amount of force is equal, means if you are applying 5 Newton and your friend is applying 5 Newton, you know what will be the net force? The net force will be the difference between two force, means minus. Okay, 5 Newton minus 5 Newton equal to 0. As a result, what will happen? You know, the box will not move. Understood? Now you see what happened. If your friend is applying force of 15 Newton and you are applying force of 5 Newton, what will happen? You know, see, 15 minus 5, the net force will be 10 Newton. Is not it? Who is applying more force? Your friend is applying more force. As a result, the box will move in this direction. Is it clear? See, okay, if the force is applied from same direction, it got added up, and if the force is applied from opposite direction, what happened? The net force is the difference between two force. Is it clear? So from this, we can say that a force can be smaller also, larger also, and it may be equal also. Okay, now let me give you one more example. You see, what happened when you are playing tug of war? Okay, you are playing tug of war, and what happened? Two teams are there, suppose team A and team B. Okay, both the team are pulling the rope. Still what happened? This ribbon do not move. Do you know why? It is because the net force is 0. Okay, both the team are applying equal amount of force. So at last one team will win, is not it? So which team will win? The team which is applying more force will win the game. Is it clear? Okay, so from this we can say that a force can be smaller also, larger also, and it may be equal also. Okay? So now we will discuss what a force can do. You see, a force can change state of a motion. Okay? See, inside this, what happened? Two topics come. Okay? See, change the speed of a moving object, change the direction of an object. So, these two are included in the state of motion. Because here what happened? Both the objects are moving. You see, the first one, change the speed of a moving object. Suppose here I have tied a pen with a rope. Suppose it is moving. Slowly it is moving. What will happen if I apply more force? It will start moving. The speed will increase. Is not it? See, now the speed has increased. Again, it is trying to stop. See, if I apply force again, the speed will increase. Likewise, what happens when a ball is moving? Okay, when a ball is moving in the ground and again you kick that ball, what will happen? Definitely the speed of the ball will increase. Is not it? From that, we can say that by applying force, we can change the speed of a moving object. There the ball was moving slowly. Is not it? See, the pen is moving slowly. So when I apply force, the speed has changed. Okay. Now the next one, okay, change the direction of a moving object. So there is one example given in your book. Okay, while giving penalty kick. Okay, while giving penalty kick, what happened? The ball is kept in the ground. Now the speed of the ball is 0. Is not it? The ball is in the ground. It is not moving. And when you apply force, how you apply force on that ball? By kicking it. Is not it? So what happened? You will kick the ball. On the other hand, near the goal post, there will be a goalkeeper. Is not it? He will try to stop the ball. Is not it? So what happened? There are two conditions you see. If the goalkeeper catches the ball, okay, what happened? The speed of the ball will be 0 again. On the other hand, if he is not able to catch that ball, what he will do? He will try to push the ball. Is not it? So what will happen now? The direction of that football will change. Is not it? It has came from this direction. It hit his hand and it went to another direction. Is not it? So we can say that a force can change direction of a moving object. One more example you see. While playing cricket, okay, the bowler is giving you the ball. Now you apply force by batting. Is not it? So what happens? The ball was moving from that direction and it came to you. When you applied force, the direction changed. Is not it? So from this example, we can say that a force can change the direction of a moving object. Okay, so keep in mind that when we say a force can change the state of a motion, both this point comes under that. It may be change in speed of a moving object or it may be change in direction of a moving object. Okay. So now we will discuss about next topic. Force can change the shape of an object. So this one is very easy, is not it? So here I have taken a square cushion. See what will happen if I apply force? The shape will change, is not it? So the shape will change only when I apply force. Okay, one more example you see. When we sit in a sofa set, okay, what happened? The shape of that sponge changes. Why? Because your body is applying force, okay, in that sponge. As a result, what happened? The shape of that sponge changes. Okay. So from these examples and activities, we can say that a force may make an object move from rest. Suppose a ball is in the ground, we can make it move by applying force, is not it? By kicking it. Now the next one is may change the speed of an object if it is moving. Just now I have given you the example of that ball, okay, which was moving very slowly. As soon as you applied force, you kicked it, what happened? The speed changed, is not it? Now the third one you see, may change the direction of motion of an object. Means what? If the ball is coming from this direction, by applying force, by hitting it with a bat, what happened? We can change the direction. Okay. now may bring about a change in the shape of an object. So just now we have seen what happened if we apply force on an object, what happened? The shape changes, is not it? Now may cause some or all of this effect. So now you see what happened. It is not necessary that every time we apply force there will be some changes. Okay. So what happens, suppose if I try to push this wall, will it move? No, the wall will not move. Okay. So now we will discuss about contact force. The term contact means what? To be in touch, is not it? Now you see there are some examples of contact force. The first one is muscular force. The force resulting due to the action of muscle is called what? Muscular force. Now let me give you some examples. You see, for lifting a book from a table, okay, and for holding a bucket of water, can you hold it without touching, or can you lift the book without touching it? Is it possible? No, it is not possible. For that we need to interact with the object, is not it? So to hold the water, what I have to do? I have to apply force, is not it? And that force, from where that force is coming? That force is coming from our muscle. Okay, that is why it is termed as what? Muscular force. Now you see, we can apply muscular force with a rope or a stick also. You see, suppose there is a snail in your garden. Now you can't remove it with your hand, is not it? So what you will do? You will take a stick and you will push that snail, is not it? So in that case, what happened? Your body is in contact with the stick and the stick is in contact with the snail, is not it? Your body is only applying force. Now you see, while workers, okay, while cutting down the trees, what they do? They pull the branches with ropes, is not it? There also what they are doing? They are applying force, and that force is coming from your muscle. Okay, that is why this things comes under what? Muscular force. Okay, since a muscular force can be applied when an object is in contact with the body, that is why it comes under what? Contact force. Okay, now the next one is frictional force. Have you ever wondered that while pedaling a bicycle, when you stop pedaling, why the bicycle stops? Or a ball rolling in the ground, why does that ball stop? Do you have any idea? See, that is because of frictional force. So now we are going to discuss about frictional force. You see, at first let us know what is frictional force. See, the force responsible for changing the state of a motion of an object is what? Frictional force. This frictional force will always try to stop a moving object. Okay? Suppose you see what happened. The ball is rolling in this direction. Here it will reach and it will stop. Do you know why? Because the ground, here the object is ball and the object B is ground. Okay? The ball is coming from this side, the force is applied from this side, and the frictional force is always opposite to the applied force. Okay? So keep in mind that a frictional force always tries to stop a moving object, and the frictional force is always in opposite direction to the applied force. Is it clear? As a result, what happened? The net force becomes 0 and the bicycle or a ball stop rolling. Is it clear? So far we came to know about contact force, not it? Contact force means when the two objects interact, okay, touch each other. So there are two types of contact force. The first one is muscular and the second one is frictional, is not it? Now we will discuss about non-contact. Non-contact means two objects are not in touch, okay? We will see what are this non-contact force, okay? Okay, now you see non-contact force. There are three types of non-contact force. The first one is magnetic force, the second one is electrostatic force, and the third one is gravitational force. Okay, so let us start with magnetic force. Okay, what is magnetic force? You see, for that I will give you one demonstration. Okay, so take two bar magnet. Okay, north south. Okay, you see these two bar magnets. Okay, what happened? The opposite pole will attract each other. This north and south will try to come close. Okay, on the other hand, what happened? The like pole will repel each other. Suppose north south, south north. Here these two are like poles, not it will try to repel each other. It will try to go away from each other. Okay, so this one you can see in this video. So students, here you see I have taken two magnets, red and blue. Two poles are there. Let us take red as a south pole and blue as a north pole. So we all know that like charges repel each other. So this red and red are like charge. See, it is repelling each other. I am trying to pull this one and it is trying to go away from each other. Okay, see. So this force is what? Magnetic force. The like charges repel each other. See, they are not willing to come together. Okay. Now you see opposite charges attract each other. This one is opposite charges, red and blue. See how they are trying to come close together. See. Now they came close together. Okay. So it is trying to attract each other. Understood? So this force is called what? Magnetic force. So the force, okay, that attract or repel the like and unlike pole, that force is called what? Magnetic force. Okay, now we will discuss about electrostatic force. What is electrostatic force? See, force applied by a charged body on a charged or uncharged body is called what? Electrostatic force. So for understanding electrostatic force, you can do one experiment. Okay, so every one of you have a ruler at home, scale. Now take a piece of paper and tear it into small pieces. Now what happened? Rub the ruler with a silk cloth or a woolen cloth. Okay, and try to take it near the pieces of paper. Okay, but keep in mind that the pieces of paper and the ruler should not touch each other. Okay, what you will observe is that the piece of paper will stick in that ruler, and the force which is pulling that piece of paper, okay, towards the ruler is what? Electrostatic force. Got it? So now we will discuss about gravitational force. Okay, you see what happened whenever something falls, suppose a flower, okay, when it falls from a tree, what happened? Directly it falls on the ground. Why it is like that? Or when you open the tap of a water, what happened? Directly the water falls towards the ground. Why? Because what happened? There is a gravitational force which pull the things toward the earth. Understood? And that force which pulls the thing toward the earth is called what? Gravitational force. Got it? So students, so far we discussed about force. Now let us discuss about pressure. What is pressure? You see, the force acting per unit area is called what? Pressure. Suppose this is the area, okay? How much force is acting here in this area will be the pressure. Got it? Now you see how you will find, okay, the formulas of pressure, again force or area. Okay, so what you have to do is you have to make a fat triangle. Make a triangle and divide it into 3 parts. Okay, so here you will write F A P, fat triangle. Now to find the area, what you will do? Area equal to F by P. Okay. Now you need to find the pressure. What you will do? F divided by A. Now you want to find the force. What you will do? F equal A into P. Area into pressure. So in this chapter, usually we are discussing about pressure. Is not it? This one. Okay. So there might be some numerical problems we need to solve. So for that, how we will find the formulas? We will find the formulas by this fat triangle. Okay. So students, now you see what happened. You need to keep one thing in your mind, that more the surface area, less will be the pressure, and less the surface area, more will be the pressure. So to prove this, I will show you an example. You see what happened. Nail, okay. When you will hit the nail from this side, okay, from the head side, then what happened? It will easily enter inside a wood plank. Is not it? Why? What happened? You see here the surface area is very small. Okay, so if we apply pressure here, so as I told you, less the surface area, the pressure will fall directly into this region. As a result, the nail will enter inside easily. On the other hand, if we do like this, will the nail enter? If I apply pressure from here, what happened? Here the surface area is more. Is not it? As a result, what will happen? the nail will not enter inside the wooden plank. Okay. Now you see one more example is given in your book. So for cutting vegetable, which side you prefer? The sharp side or the blunt side? Why you prefer the sharp side? Because the sharp edge has very small surface area. As a result, what happens? The pressure will fall directly and it will be very easy to cut the vegetables. Is not it? Now, one more example is given in your book. See, when a porter, okay, while carrying heavy luggages, what they do? They put a piece of cloth over their head. Why? You see, when they will put a piece of cloth over their head, definitely the surface area of our head will increase. Is not it? So, as a result, the pressure, okay, the pressure which falls on our head will be reduced. Okay? Now, one more example you see, your school bags. Your school bags have a very thick straps. Why? It is nothing but to reduce the pressure of your bag. Is it clear? So, now we will discuss about pressure exerted by liquid and gases. So, first we will discuss about pressure exerted by liquid. So, students, you see, before entering into this topic, we need to learn one very important thing. Okay, you see what happened? The pressure increases in liquid and gases with increase in depth. Okay, suppose this is the depth. Okay, at the top, what happened? The pressure will be less. In the middle, the pressure will be moderate, and in the lower region, okay, the pressure will be more. For understanding this, we can try this activity. So, you need to take 3 bottles, bottle A, bottle B and bottle C. Now, make a hole. In bottle A, make a hole at the top. In bottle B, make a hole in the middle. Okay, in bottle C, make a hole in the bottom. Okay. Now, you see what happened? Pour water in bottle A, B and C. In bottle A, you will observe the water will fall, but the pressure will be very less. Okay, the pressure will be very less. As a result, it will fall very near. It will not go up to long distance. On the other hand, in bottle B, what happened? The pressure will be moderate. Is not it? So, the water will fall quite far away from the bottle. And in the bottle C, what happened? See, here the depth has increased. Is not it? The hole is very down. As a result, what happened? The water will go and fall very far away. So, is it clear? From this experiment, we can say that water also exerts pressure. And the pressure increases with increasing depth. Okay? Now, we will discuss about pressure exerted by air. Do air exert pressure? So, for knowing the answer, we need to understand this example. So, what you have to do is take a balloon and inflate it. Okay? What will happen? The balloon will become bigger, is not it? Why the balloon is becoming bigger? You see what happened? The balloon is becoming bigger because the air we are blowing inside, okay, is applying pressure on the wall of the balloon. As a result, what happened? The size of the balloon increases. Okay? Now, what will happen if there is a hole in the balloon? Will the balloon become big? Will the balloon will become bigger? No, the size will not increase because what happened? The pressure which we are applying is not it. By inflating air, it will go outside from this hole. Okay? Like so, from this we can say that air also exerts pressure. Is it clear? Now we will discuss about atmospheric pressure. What is atmospheric pressure? You see, the pressure exerted by the air is called what? Atmospheric pressure. Now you see what happened. This one, suppose this is our earth and our earth is covered by a blanket of air called what? Atmosphere. Is not it? Now what happened? As I told you that what happened? The pressure of air and liquid increases with increased depth. Is not it? Now the distance from
So students, here is one diagram you can see. What happened? You see the atmospheric pressure, okay? At high altitude, it is very less. In the middle region, what happened? It is quite moderate. But in sea level, what happened? The atmospheric pressure is more. Why it is like that? It is like that because what happened? Pressure increases with depth, okay?
So students, this is all about our chapter Force and Pressure. If you have any doubt, you can ask me. Thank you and have a good day ahead.